Hi, my name is Pascal, and today I want to talk about blueprints of successful GraphQL architectures. I work for a company called ChilliCream, as you can see here. And we are very active in the open source space, where we maintain our server, Hot Chocolate, which is written in .NET. And we are also known for GraphQL Fusion, which is a fully open source federation implementation, which is also part of the basis that we use for the composite schema specification, which we're also part of. We also do tooling, namely Banana Cake Pop. We have many funny names. And with Banana Cake Pops, you can share documents, you can manage your APIs inside of your team. Here you see a federated gateway, and you can also have monitoring. We have an open telemetry endpoint where you can send your data and really get this deep insight into your application. We also work together with a lot of companies, a lot of enterprises of any size, small companies, big companies, and help them along in their GraphQL journey. Over the last couple of years, we have seen a lot. We have seen a lot of patterns that repeat itself across different companies. And today, I want to talk about database first, GraphQL layer, and enterprise app, which are three patterns that we have seen in companies. Little disclaimer up front. Whatever you do, if you see yourself doing one of these patterns and it works for you, do not think about changing it if you do not see any reason for it. So it's not wrong to do database first or to do an enterprise app or something like a GraphQL layer. So just use whatever works for you best. So let's start with database first. And as the name suggests, at the center of database first, you have a database. And in front of this database, you have a GraphQL API. And when a request is made to this GraphQL API, the request is taken, compiled by the API into a SQL statement, and executed on the server. There's many tools that you can choose from to do this, namely Hasura, dgraph, or Prisma, and also MongoDB with MongoDB Atlas. Although Prisma does no longer use GraphQL for their client, and MongoDB deprecated actually their Atlas support, where you can put a database in front of a GraphQL API in front of your database. So why is that? Well, it turns out a GraphQL API is much more than just a database. You want to have authorization on a GraphQL API. You want to have authentication. You want to add your business logic. You want to extend it by integrating a REST API. You may want to reshape your GraphQL API. And therefore, it's much more than just a database. So it turns out that that database first was always GraphQL first. And now you have even more tools that you can choose from. For example, the famous Postgraph file, which can do all of these things, and you can actually maintain a good schema. And there's also GraphQL server which support this pattern, like ours. And we support this pattern by implementing resolvers in .NET, and there you can then also map your database. So why do enterprises use this pattern? It's because you're crazy fast. You're so fast that we can now, in fact, build together a GraphQL server in hopefully less than 30 seconds. So let's open code quickly. There we go. So this is a .NET application, which uses an ORM called Entity Framework. And now there's no GraphQL API on this server at all. What we can do is we can add a GraphQL API. Let's first add a query type. Like this. And then we say that we want to expose the products, and we want to use pagination. We want to use projections. We want to use filtering, and we want to use sorting. So now this is our query type that we'll query in a second. Now we have to configure the GraphQL server. And what we do here is we add the GraphQL server to the application, register the query type, add filtering, sorting, and projections. And now, with a bit of luck, we can just run this. Nope. I think it's example 1. Let's see. Here. And when we open the API, we should now be able to query the products. No, thank you. Products, and we can, for example, select the nodes. So remove this. And remove the fields which do not work. There we go. And we have a fully functional GraphQL API from the database with implementing one resolver. Now, you have also the possibility to actually write filters here. For example, where the available stock is equal to 100. And then you only get, well, that's not so interesting, but it would filter. And you only get the values that these filters define. So you see, it's very easy to build APIs with the database first. You're very fast. You have high iteration speed. And you have various tools to choose from, like the ones I showed you before. The problems that you have is that you have a very tight coupling between your database schema and your GraphQL API. And you may not actually want to have that, because your database usually changes. And when your database changes, you don't want that your GraphQL schema also changes. That makes change management really difficult. And you're likely to expose internals like join tables or something like this. And this is a bit a personal issue that I have with it. In GraphQL, it's a good practice to follow the you ain't gonna need it principle. Now, when it's more work to hide a property from the GraphQL API than to add it, you're more likely to expose it just because it's less work. And with each field that you expose in the GraphQL API, you add a new liability to your GraphQL API, because then you have to go to the whole change tracking flows, you have to go to deprecation the fields, you have to remove it, and so on. And it's a bit of the hot chocolate problem that we have here. It's a bit limiting in flexibility. You cannot just add any field. It's difficult to shape the schema in a way that you want instead of just mapping the database through. I see a lot of companies start with this approach, and later in the journey, they go to a different approach, for example, into the GraphQL layering approach. Instead of directly calling the database from the GraphQL layer, you call a business layer where your business logic sits, and from there, you call the database. An advanced version of this pattern looks like this, where the business layer loads the data over data loader. Therefore, you have all the nice caching capabilities of data loaders, and you still mutate directly on the database. With this pattern, you have a really thin layer on top of the business logic, and this is more or less also what Facebook did in the beginning. They didn't map a database. They mapped their business logic and expressed the business logic in GraphQL. You see, the benefits are quite clear. You isolate your business logic, which means it's easier to test and it's easier to reuse. And it gives you more flexibility, because you don't have to worry about schema changes that much. You have still to worry about it, but you have it hidden in the business logic. You have more control over it. And this pattern, specifically, scales very well, which means that the cost of adding a new feature more or less stays the same over the time of the project, rather than increasing because the complexity of the code increases, while the performance stays the same. And again, this is a bit of a hot take. I say by separating the GraphQL layer, the database and the GraphQL API, you produce better schema, just because you have to do it by hand. And people tend to care more for things that they have done by hand instead of just auto-generating it. It's not impossible to have a good GraphQL schema with all the best practices with the other approaches. It's just a bit harder to do. The problems are very clear. You have another layer of complexity that you add, and you have a slower iteration speed. It's also harder to optimize this pattern, because the business logic should not know that it's called by the GraphQL API, which means that when the GraphQL API makes a call, the business logic does not know which field are selected. Therefore, you cannot really optimize and do optimal fetches. Now, I do recommend this pattern to a lot of people because it's simple and it scales really well. But why do some companies, especially big enterprises, choose a different strategy? So let's talk about these enterprise apps. And let's begin by asking, what even is an enterprise app? And Gartner defines it like this. Enterprise applications are systems that run all phases of an enterprise operations to integrate core business processes like sales, accounting, finance, HR, and so on. So what does that mean? An enterprise does not only consist of just their business processes. They have multiple of these pillars like sales, inventory, and accounting. These pillars make up the enterprise. And when an enterprise grows, it will inherently have more of these pillars for each value stream. So maybe you have started as an insurance company and you do B2C, and then you start doing different insurance models. You acquire a company, then you have B2C, and then you have enough money to actually have asset management. You acquire again a company, and then you do asset management as well. And then you have 3 companies which together are a big enterprise consisting of different business units. Now the problem was 20 years ago, digitalization struck. And companies at this scale still struggle to define an API which defines their whole business domain. So how do you even handle the complexity of these systems? And how do they build software that scales at this level? They use common helpers and patterns like CQRS and domain-driven design. This seems unrelated to GraphQL first, but you will see that it matches quite well with what we do in GraphQL. So let's start with CQRS. CQRS stands for Command Query Responsibility Segregation, which means that basically you have separate read and write models. And this makes sense because read and writes have different scalability requirements. You usually read data much more often than you mutate it. And when you mutate data, it's also fine if it takes a bit longer because the user expects that changing the profile picture takes a bit longer than just loading the product page. And by using CQRS, you can reduce the complexity in data handling because when you have a command that is, that was one too many. When you have a command that is a task-based interaction and change something like checkout, then it's much easier to look at this in isolation rather than having a whole application to deal with it. So commands, the C in CQRS, stands for mutations. And the queries, where you request data, the read models, which are purely informational, map very well to the queries that we have in GraphQL. The benefit of using CQRS is that you can separate these concerns and you can optimize for read and writes. And mutations get a bit simpler because you can isolate these commands. The problem, again, more complicated, and you have more boilerplate code. If we switch over to domain-driven design, things get a bit more interesting. Because in domain-driven design, we have 2 core principles. We have a ubiquitous language, and we have model-driven design. And a ubiquitous language is a common language between the developer and the stakeholder. And with DDD, you have a whole suite of tools that you have at your disposal to help you build a system together with your stakeholder. For example, this is an image of event storming where you are at the board and you build with the stakeholder together your application. And the other benefit is that you have model-driven design, which means that your system that you build is based on a model, which allows for emulation. That means before you actually implement it, you can see and verify that you actually built the right thing before you even write a line of code. And we do have that as well in GraphQL. It's very surprising how many companies do not know how their own business works. Like, if you ask a developer, a PM, and a PO what they do in their company and how it works, you usually get 3 different answers. And sometimes none of these answers is the correct one. By modeling, you get this this common understanding on how the company should work, and you can build a product together. So with GraphQL, you have these capabilities as well, because you have the GraphQL schema, where you can sit together with your stakeholders, with your product managers, and you can do schema planning meetings where you come together and you actually plan how the next version of your application should look like. So the tip of the day is you should think before you do. So before you actually do a change, think about if it makes sense how you do it. In DDD, there's 4 different building blocks. You have entities, you have value objects, you have aggregates, and repositories. An aggregate is a thing in your application. For example, an order. And an aggregate can contain value objects, like an order name. It can contain enums, like an order status. And it can contain related objects, like order item and address. These building blocks, they map as well really good to GraphQL. For example, an entity, order, is a node. And a value object is a scalar. And the aggregates are the types in your system. And the repositories are your root fields. In DDD, there's also a concept of bounded context. And the people which work with DDD have definitely heard of this buzzword before. And it's a collection of aggregates that you put together under the same name. For example, you have ordering, and ordering consists of order, and it consists of user. An application can have more than one bounded context. For example, the catalog API maybe is its own bounded context, and identity is its own bounded context as well. With GraphQL and federation, this makes now a lot of sense, because in DDD, as well as in federation, a type or an aggregate can live in different bounded contexts at the same time, which means that the user in identity can contribute to the global schema as well as the user which is in ordering. And by this separation, when you put these bounded contexts into microservices, you can actually choose different architectures for the different subgraphs. For example, you can say that the identity is a very simple service where you only want to expose the database directly, so you do GraphQL first. Or maybe you have, in product, a slightly more complicated API where you use the business layer approach. And maybe the ordering is a very complicated service, and then you use clean architecture. And clean architecture is a pattern that we .NET developers really like, because it makes our project much more complicated than they actually have to be, and we are pretty good at doing that. In DDD, there's also a concept of events. And there's 2 kinds of events. There's domain events, which define the side effects that happen inside an aggregate and notify another aggregate. So you, for example, it could be that an order was placed, and then you have to modify the user, which is also in the same aggregate. And then there's also integration events. And integration events are used to send notification between 2 different bounded contexts. So for example, inventory check was requested, you expect an answer, this goes over Kafka or whatever message bus you use, over to a different service, and you get a response. And these are more like coordination events, and usually they're triggered by domain events. And events in GraphQL are just subscriptions. Please do not expose all your events as subscription endpoints, but they're very easy to hook into and to then create subscriptions based on it. Okay. The benefit of using DDD is that you have a very close alignment between your software and your business needs, because you have planned the software together. And it's very easy to evolve such an application because you have abstracted it so much. And it's very scalable because the components are decoupled. The problem is, and you may actually want to have the first problem probably, is it requires a deep understanding of your domain. And this is very time consuming, and you have to have very skilled people, very skilled domain experts and developers that work on this modeling in the first place. If you combine the two, you have a very clear understanding of what your business does, and it scales to any org size. And the biggest benefit is that you have a very clear path from business to product. So one person in the business team comes up with an idea, then you model it, and you can build it into your product. And it just goes like this because you have built your application in a way that allows for this. The problem is it's very complicated. You have to commit to it. You have to stick with it. You can not only do partial DDD, either you do it fully or you just better leave it, and it's very cost intensive. So my last hot take today is that the only way to make these big, huge applications accessible to clients or to consumers of any kind is to use GraphQL to combine the different bounded contexts together and expose a unified API. If you want to learn more about this, you can go to learnChilliCream.com. We do workshops where you can learn more about this. It's .NET workshops. I don't know how many of you are .NET developers, but we have an enterprise application workshop coming up. So if you're interested, you can follow the link. If you have any questions, feel free to ask them now. Otherwise, yeah, please.
Maybe in domain-driven, you mentioned that people have like a user that is different for the different domains, basically.
Yeah.
Would that transform in different user type in the GraphQL?
No. You would have one type. In Federation, you would have one user type on all the subgraphs, and you would merge them together into one type in the schema. It could be, in this example, that maybe you have on the ordering subgraph, you have the orders of the user, and the name and the address are in the identity. And then you basically compose them together into one new schema. Any other questions? OK. Otherwise, thanks a lot for listening. And if you have any more questions, you can either shoot me an email or find me on Twitter. Thank you.